All right, everybody, welcome back. You've kind of already seen a couple different videos about gravity and learning a little bit more about that. Well, I want to take that kind of a step further. And so you can see you got at the Taj Mahal, so we're taking a little bit of a trip. I actually got to go there in 95, in the fall of 1995 as a study abroad. When I was in college as an undergraduate, probably maybe before some of you might have been born. But yeah. So what we're going to do is we're going to talk a little bit about gravity. So let's kind of go ahead get started. Now, if you say gravity and you say, oh, that's the force of something, I'm going to go, no, 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 no. Okay. A lot of textbooks call it that way and they just get it wrong. We use it in our everyday language as a force, but it's not. Our weight is the force of the earth pulling us down, and gravity is actually the acceleration. So if I drop something, how what's the acceleration of that object towards the center of the earth? That's what our gravity is. That's what our constant is. Now, acceleration, we can say of it as in 9.8 meters per second squared. That's what gravity is. It's also, if we put it in the English system, which we're the only ones that use it. No, I think there's one other country somewhere else that might, but for the most part, we're the only ones that use the English system, of 32.2 feet per second squared. Now, acceleration, remember, it's a vector, but it's how quickly our velocity is changing. What's the magnitude of change in our velocity? So, like if you're looking at sports cars or something like that, they might say 0 to 60 miles per hour in 5 seconds. Well, that's a change in velocity over a change in amount of time. Well, gravity is an acceleration. We know that weight is the force of the earth pulling us down, and that's equal to mass multiplied by gravity. So the more massive I am, the larger the weight is. And this is also leads to a little bit of confusion between mass and weight. Weight's a force. Weight can change. We talk about, oh, I need to go on a diet, I need to lose some weight. Well, I can help you lose some weight. Get in an elevator at the top floor and hit the down button. Your weight's going to go down. Your mass doesn't change. So what we're really concerned about is changing the amount of mass that we have in us. Weight, if I go to the top of Mount Everest, I'm going to weigh less than I will at the bottom of Death Valley. So again, it's another issue where terminology can be a little bit confusing. Remember that weight is a vector, weight is a force, mass is a scalar. Mass only has a magnitude. So mass is how much stuff there is inside of me. Remember, it's like inertia, resistance to change. But Newton came up with the law of universal gravitation. And the gravitational force between two objects, every two objects have a gravitational attraction to each other. So if we were sitting in class, I would say that you are attracted to the person that you're sitting next to gravitationally. That's 100% accurate. You have a mass, the person you're sitting next to would have a mass. Two masses exert a gravitational force on one another. So there isn't a force of attraction. Now it's incredibly small, but there is that force there. So when we're talking about us, the two objects when we're looking at my weight is us and the earth. So when I look at here, force of gravity, the force of the weight, it's my mass multiplied by g, which is that 9.8 meters per second squared. But that g is based off a whole bunch of different constants. Mass of the earth, g, which is a gravitational constant, which is kind of like, think about it like I got these two ratios, I plug this value in, and everything works out nice, divided by the radius of the earth squared. Now, we're not going to get into the math too much, but I do want you to know some of this stuff, because as we're talking about the nature of science, one thing that we really never talk about is the history of science. You read these equations, you hear about these concepts. How did I come up with this? How did Newton come up with these things? Like, g is the acceleration of the earth pull. We know it is 9.8 meters per second squared. How do we come up with that? Big G, little g, is the gravitational constant. 6.67 times 10 to the negative 11th newtons kilogram per kilogram squared meter squared. How do we come up with that? Seriously, how do we know what this is? The mass of the Earth is 5.97 times 10 to the 24th kilograms. How do we get that? We talk about these values, but we never really get into the history behind it. And I think that's one of the things that really lacks in our public education system is we don't get the historical aspects of it. And yeah, the mass of the Earth is 5.972 septillion kilograms. And yes, I'll admit I had to actually look that up. R of E is the radius of the Earth, 6,378 kilometers. Now, what's interesting is that's the equatorial radius. The polar radius is actually slightly less. And you're going to come out and find a little bit later that Jupiter, there's actually a 6% difference. It's a much bigger difference between equatorial and polar radiuses. But this equation is all constants. Nothing changes for here on Earth. G is a constant, little g is a constant, big G is a constant, mass of the Earth is a constant, radius of the Earth is a constant. So here's a question. I want you to pause the video after I ask you this question. You saw that equation. There's 4 different things. What do you think was discovered first? Was it the acceleration due to the Earth's pull? Was it this big gravitational constant? Was it the mass of the Earth? Was it the radius of the Earth? What I want you to do is I want you to rank them. Which one was found first? Which one was found second? Which one was found third? Which one was found fourth? So if you think the mass of the Earth was the first thing we knew out of these 4 things, that would be a 1. If you think the acceleration due to Earth's pull, in this table, little g, you would put a 1 there. And then, after you rank them, I want you to think about what decade was it founded. Do not use Google. Do not look things up. But just think, when did we discover this? When did we find G? When did we find big G? When did we find the mass of the Earth? When did we discover the radius of the Earth? So pause the tape, fill in this table on your answer sheet. Okay, so now that you filled in the table, here's the answers. Out of these 4 things, the first thing that was discovered was the radius of the Earth. Now, I want you to pause and think for a second before we do anything else. How could you figure out, how could you calculate the radius of the Earth? Come up with some ways and just label some things as to how I could calculate the radius of the Earth. All right, so now that you've thought of at least one method to calculate the radius of the Earth, now I'm going to throw in some dates. So we already answered these questions. How do we calculate the radius of the Earth? How do you think it was calculated? Now I'm going to throw in the dates. The radius of the Earth was actually discovered in 240 BC. That was the first time that we had a fairly good estimation of the radius of the Earth. Little g was next, but that was pretty much 1900 years later. So I get blown away by this every single time. I want you to think for a second. Again, don't use anything Google, don't look anything up. But how could you calculate the radius of the Earth in the year 240 BC? So we're going to do an activity, but before we do the activity, because we're actually going to, I want to show you how it was calculated. And that's part of the history of science activity we're going to be doing is you're going to actually do those calculations and come up with how big and learn about how it was done. But I want you to try to see if you can figure it out first for yourself. So think about it. Answer the question, how big do you think, or how do they calculate the radius of the Earth? And we're going to talk about that in the next video.